Vanakkam. Today we're graphing our quadratic functions by using 5 critical points. Alright, so on the left I'm going to show you the steps, and on the right I'm going to show you an example using those steps. So our first step is going to find the axis of symmetry and to graph it. Little reminder, your axis of symmetry is always x equals a number. Specifically, it's going to be negative b over 2a. And please remember, that's a 2a. So in this example, to find our b and a, you need to make sure it's in standard form. And yeah, that's in standard form. So let's find our a, b, and heck, while we're at it, let's find c. And warning, you'll want to write small. I didn't give a whole lot of room on this example side. All right, our value for a is 1. Our value for b, our coefficient, is 6. And c is 8. So our axis of symmetry is negative b over 2a, so negative b over 2a. b is 6, a is 1. Well, we get negative 6 over 2, which is negative 3. So that means my axis of symmetry is x equals negative 3. So now I'm going to show you what that looks like on our graph. Here's our graph. So we're looking at our x-axis, and I see negative 3 is right here, so I'm going to draw a line through that. I know it's not very easy to see, so hopefully yours is easier to see. There we go. X equals negative 3. That's our axis of symmetry. Now we need to find our vertex and graph that. Remember, the vertex, that's the highest point or lowest point of the graph. The x value of it is negative b over 2a. And our y value is f of that number. In other words, our y value is whatever we get when we plug this into our equation. So we already know negative b over 2a is negative 3. We just need to find the y value. So look at your original equation, and anywhere we see an x, I'm going to put some parentheses. And now in those parentheses, we want to replace x with negative 3. And you can solve this by hand if you want, or just type exactly this into your calculator. You should find out that y equals negative 1. So that means our vertex must be at negative 3, negative 1. So let's look at where that is on our graph. Remember, to graph, first do your x value. So we go over on our x-axis to negative 3, and then we go down to negative 1. And we put a dot there. That is our vertex, that point right there. Go to the next step. All right, we need to find the y-intercept, and I'm going to change colors so we can see it better. To find the y-intercept, you're going to substitute 0 for x in the original equation. Here's the good news. There's a kind of cheat to this. I know, cheating. I'm awful. If your equation's in standard form, the y-intercept is 0, comma, c. So let's look back at our original equation. We said c is 8. So that means our y-intercept must be 0, comma, 8. That was easy. Let's plot it on the graph. So 0 means we don't go left or right at all. We just go up to 8. There's our y-intercept, because the y-intercept has to cross the y-axis. Cool. Next step. Now we want to plot the mirror point of the y-intercept, which means we're going to treat that axis of symmetry like a mirror and reflect our y-intercept. Here's what I mean by that. So here's our y-intercept. here's our axis of symmetry. So notice our y-intercept is 1, 2, 3 away, 3 units away from our axis of symmetry. So from our axis of symmetry, let's go, keep on going, 3 more. 1, 2, 3. So now this axis of symmetry is exactly between our 2 points. So don't go up or down at all. Just think left to right, because that's what the mirror would do. All right, next step. It says we need to find our zeros by using the quadratic formula. We hate it so much. I know, it's so awful, but it is also super, super helpful. And a little reminder, zeros, that means the same thing as roots. It means the same thing as x-intercepts. So let's find those. Do you remember the quadratic formula? If you don't, it's on our little reference sheet. So x equals negative b. Remember, do your skeleton first. Plus or minus square root b squared minus 4ac all over 2a. Let's fill in with some numbers, shall we? So we said b is 6, a is 1, c is 8, and one more time, a is 1. All right, when we do some solving, well, negative 6, that's negative 6. Plus or minus. When I plug this into the calculator, 6 squared minus 4 times 1 times 8, I got 4, so square root of 4. And hopefully we all know that 2 times 1 is 2. Oh, this didn't need to be so long. There we go. All right, we need to split this into 2 different problems. We need to do negative 6 plus the square root of 4 over 2. And we need to do negative 6 minus the square root of 4 over 2. Well, when we do this, we get x equals negative 2. And over here, you should get x equals negative 4. So that means our x-intercepts, or our roots, or our zeros, whatever you want to call them, are at negative 2, 0, and negative 4, 0. All right, let's plot them. So negative 2, remember, go left or right first. 0, it has to be on the x-axis. And then negative 4, 0, which is right here. Our last step, connect all your points with a smooth curve, or as smooth of a curve as you can do. So mine might be a little crooked. Try not to judge me too much. So start at the top and make a nice smooth curve. Oh, that's not too awful, right? Yeah, I've seen better, I've seen worse. And that's how you plot it. So that's not a bad parabola, if you ask me. All right, you've got some practice. Get to it. Let me know where I lost you, where you have questions, because I am here to help.